All right, let's get started. Now, today's session will be a very comprehensive one, okay, on organic chemistry. Today will be the last day, as mentioned, of our September crash course. So I hope that for students who have followed me through the last 3 days, you are able to gain something from the crash course. Okay, come. Okay, let's start off with what we learned in organic chemistry. In the first part, organic chemistry, we learned the introduction, right? So we learned that organic chemistry, most of the time, we are studying organic compounds. Organic compounds are carbon-containing compounds. Okay, so for those of us who have the notes, you can write down on the notes. If not, a piece of paper would be good as well. Okay. So carbon-containing compounds, normally we say that they are organic compounds. The definition is that they are carbon-containing. Okay. So what is a crude oil or petroleum? This is known as a long-chain hydrocarbon. Okay, for the sake of today's lesson, I will write in HC. HC stands for hydrocarbon. Now, what does that mean? It means that if I go down to the ground and dig up all the fossil fuels, you will realize that in this composition, there are fossil fuels of all different carbon length. That means that there are some fossil fuel, or rather there are some organic compound with maybe 10 carbon, 20 carbon, 80 carbon, 70 carbon, 200 carbon in one chain of organic compound. So we call them long chain organic compound or hydrocarbons, okay, because all of these, they have different carbon length. Okay, so this is the first part of organic chemistry. This is what we study. Now, my next question to everybody is, if let's say I have this sample of many different type of carbon-containing compounds, how then am I able to separate it into the compounds based on what I want? Remember, there is this thing whereby we feed crude oil into this chamber, and this chamber, there are different outlets. There are top, there's middle, and there's a bottom. Can you tell me what is this process known as? Very good. Thank you, Jingwen. Thank you, Rachel. It's known as fractional distillation. Thank you, Sinan, as well. Okay, so this process is known as fractional distillation. And can anybody tell me what is the principle that fractional distillation works on? Yes, very good. Very good. Okay, separate the fractions based on different boiling point. My next question is this. Different boiling points is a carbon 10 versus a carbon 70. 70 carbon in one length, one chain, versus a 10 carbon in one chain. Which one have a higher boiling point? The longer one or the shorter one? Higher boiling point. Longer one, Ingrid, longer one, Sinan. Okay, very good. So, number of carbon, okay, is proportional to the boiling point. That means that when the number of carbon increase, the boiling point also increase. Okay, this is because when we are talking about molecules, okay, they exert weak intermolecular force of attraction, right? So when there is an increase in the number of carbon, the molecular mass increase, remember? So the molecule become heavier. When it's heavier, they can exert a larger intermolecular force between their counterparts. And that's why more energy is required to overcome these forces, bringing back chemical bonding, hence there is a higher boiling point. So you need to see the link. Can? Okay, so this is on fractional distillation. Now, let's go on to chapter number 1. After we have studied about petroleum, we go on to study about organic compound. Okay, so end of today, you will see that this page will be filled up very full, and there will be a lot of things inside there. Okay, so there will be organic compound. Now, organic compounds, most of the time, they contain carbon. Okay, most of the time they contain carbon atoms. Now, organic compound, whenever we talk about organic compound, we talk about this thing known as family of organic compound. Can anybody tell me what is the chemistry name for family of organic compound? Type inside the chat for me. Jingwen says homologous series. Anybody have different answer or same answer? Okay, Jingwen homologous series Ingrid also say homologous series. Okay, good. Yes, you are right. Okay, so we call it the homologous series. Okay, a homologous series is a class of organic compounds, is a family of organic compounds. Now, in this homologous series, there are two characteristics that you need to be aware. The first characteristic is they must have the same general formula. That means what? That means the ratio of atoms, okay, the ratio of atoms of each element in the homologous series must follow a certain ratio. For example, alkane will be CnH2n plus 2. For alkenes will be CnH2n, etc. So this is what is known by general formula. Now, second thing is it must contain the same functional group. Okay, same functional group. Now, I'm going to give you this analogy for students who don't understand what is the difference between homologous series and functional group. Now, functional group is a special characteristic that the family has for it to be the family. Now, I will say, for example, if let's say somebody, surname is Tan, surname is Ko, surname is Ang. Now, these are three different family, right? Three different family. Now, in each family, what is the characteristic? Maybe let's say I say the Tan family, everybody have blue eyes. So can you see this is the functional group? The functional group is the characteristic that makes the people from Tan family the Tan family. Can you see? Okay, so this is the homologous series. The functional group is the ones inside the homologous series, the people that make up the homologous series. Okay, they must exhibit a certain characteristic. Now, after we talk about homologous series, the next thing we talk about is the first class of organic compound. We call them alkane family. Okay, alkanes family. Now, can anybody tell me, whenever we are looking at different homologous series, first thing to identify is their functional group as well as their general formula. Now, alkanes, what is their general formula? Does anybody know put inside the chat? Anybody have any idea? Yes, thank you, Jingwen. CnH2n plus 2. Okay, so this is the general formula for alkanes. Next. Alkanes, is there any functional group? If yes, type yes. If no, type type no. No, okay. Says no, Rachel says no. Okay, good. So there's no functional group. Okay, so I always tell my students, alkanes is very boring people. They don't have any special characteristics. They just have black eye, black hair. Okay, normal. Okay, there's no special characteristic about them. There's no distinguishing factor about them. But one key important thing you need to know is that alkanes has this property. They are known as saturated hydrocarbon. Okay, saturated hydrocarbon. Now, I want to clear a misconception over here. The term saturated, I think most of us understand the term saturated as carbon single bonds. Okay, that is a chemistry textbook way of understanding. But you realize that actually in the chemistry way of understanding, saturated means what? Saturated, the formal definition of this is where the carbon atom is bonded to the maximum number of 4 other atoms. That means that carbon form 4 bonds like that. 1, 2, 3, 4. This is what is meant by saturated hydrocarbon. Okay, it's bonded to the maximum of 4 atoms. This is what is meant by a saturated. Then when we say something is unsaturated, don't write there carbon to carbon double bond. That's not the definition. The definition for not saturated is carbon atom is not bonded to the maximum of 4 atoms. That means they're bonded to 3 atoms. For example, a carbon to carbon double bond. Can you see? This carbon is bonded to 1, 2, and 3 other atoms only. Although, yes, there are 4 bonds, right? But they are only bonded to 3 other atoms. Okay, so this is for alkanes. Now, alkanes follow this formula, CnH2n plus 2. They are a saturated hydrocarbon. My next question to everybody is, for alkanes family, what kind of reaction can alkanes undergo? How many type of reaction? Can you type inside the chat? How many type of reaction does alkane undergo? Somebody say 3, somebody say 2. Okay. Kaiji say 2, Rachel say 2. Hi, Kaiji. Ingrid, Hashim say 3. Okay, answer for alkanes they undergo two general reactions. Now, the first reaction is known as combustion reaction. Now, combustion reaction means what? Everybody say again, alkanes is a hydrocarbon. Hydrocarbon is a fuel. Combustion to produce energy. So what does it combust with? It combusts with oxygen. Combustion with O2. This is the first reaction. Okay, yes, Sinan, generally unreactive. Okay, alkanes are generally unreactive, except for these two reactions. Now, the second reaction is known as the substitution reaction. Okay, the substitution reaction. Now, question to you. What do alkanes undergo substitution with? What do alkanes undergo substitution with? Okay, Sinan says chlorine. Chlorine, okay, reactive halogens. Okay, good. So substitution reactions with halogen. That means what? That means it can react with chlorine. Most common is chlorine. Less common will be bromine and iodine. They can form substitution reaction one. Okay, this is for your awareness. In case section B question asks you. Good. Okay, so this is for alkanes. Any questions so far? Later we talk about substitution mechanism later. Okay, how does substitution occur? Later I will tell you. Now we go for a broad overview, a broad summary of this verse. Okay, for students who just joined, if you need to take a photo of this, you can go ahead and take a photo. Okay, we'll be adding on to this mind map. Okay, any questions so far? If no question, can you give me a thumbs up so I can proceed to the next part? Okay, now, okay, thank you, Jingwen. Thank you, Zinan. Okay, thank you, Cheryl. Thank you, Izati. Thank you, Ingrid. Okay, good. So my next part will be now, after we look at alkanes, what is the second chapter that you study? You will study this thing known as alkenes. Okay, alkenes, alkenes. Now, my question to you is this. If I have a very big alkane molecule, if I want to get from alkane to alkenes, what is the process that I take to undergo? Okay, says cracking, Jingwen says cracking. Okay, good. Anybody else have a favorite answer? Okay, Okay, so the process that we take to go from a big chain alkane to a smaller alkene molecule is known as cracking. So when I crack the big alkane or big hydrocarbon molecule, what am I doing? It is actually the process of breaking up large hydrocarbons to form smaller hydrocarbon. My question is, why is it that I want small hydrocarbon instead of large hydrocarbon? Exam will ask this kind of question. Why is it that I want to undergo cracking to form small hydrocarbon? Why is it that large hydrocarbon I don't want? Okay, yes, Rachel, more profitable because it's higher in demand. All right, produce plastic and fossil fuels like petrol. Yes, so the whole idea of it is small hydrocarbons, they are higher in demand. That is the reason why I undergo cracking, right? Yes, correct. Okay, there are more users for the smaller hydrocarbons. Okay, so this is an industrial question or this is a real life question, a real life application. Why is it that a lot of companies, they don't like big hydrocarbon, they like small one? Because it's very useful, can make cooking oil, can make petrol, can make a lot of different stuff. Okay, now, so this process help us to get from alkanes, the first homologous series, to the second one, alkenes. Now, alkenes, same goes, we will continue. First thing to do is identify what is the general formula. Quick, everybody type in the general formula for alkenes. Ingrid, thank you. CnH2n. Very good. Okay, Jingwen, this one is alkenes, CnH2n. Okay. Now, second question. Does alkenes have a functional group? If yes, can you type down what is the functional group? If not, can you say no? Okay, so it is a CC double bond. This is its functional group. Now, there will be implication why CC double bond will result in certain type of reactions. Okay. Now, when we call it a CC double bond, that means what? That means each of the carbon atom can bond to two other groups, like that. Okay, they can bond to two other groups. Because carbon contain 4 bond maximum, right? So carbon, 1 bond, 2 bond, 3 bond, 4 bond. These carbon atoms same goes 1 bond, 2 bond, 3 bond, 4 bond. Okay, so there's only one group here, one group here. And there's one group here, one group here. Okay, so it looks a little bit like a spider shape. Okay, CC double bond. Now, when there is a presence of CC double bond, carbon is no longer bonded to the maximum of 4 atoms. They are now bonded to 3. And what do we call this? Very good. Okay, we call it a unsaturated hydrocarbon. Okay, I will say again, unsaturated means what? Carbon atom is not bonded to the maximum of 4 atoms. Okay, they are only bonded to 3. Okay, these carbon atom, 1, 2, 3. All right. Okay. Next question is, alkenes family, what kind of reaction does it undergo? How many reactions do we have? Very good. Very good, Ingrid. They undergo addition reaction, right? Jingwen, thank you so much. They also undergo combustion reaction. Okay, so let's settle the easier one out of the way first. They undergo combustion reaction. Same goes. They undergo combustion in the presence of oxygen. This is the first thing you need to understand. Okay, alkenes undergo combustion with oxygen. Same goes for alkanes. All right. Okay, good. Now, alkenes, they undergo addition reaction. This is because of the carbon-to-carbon double bond. Can you see that when the double bond, one of the double bond breaks, 2 electrons are free up. 2 electrons are free up. Now the carbon can connect another 2 bonds like that. One bond to the left carbon, the other bond to the right carbon. Okay, so generally alkenes will undergo this reaction known as the addition reaction. Now, under addition reaction, there are 3 other types of reactions we need to know, or 3 different types of reaction to know. But don't be worried, because whenever we look at alkenes, the only reaction I need to remind myself is addition. Later, I will explain to you why. Why all the 3 sub-reactions of addition reaction are the same one. You don't need to memorize all 3 different. You just need to make sure that you understand one. The rest, you will know. Okay? Come, let's try together. Now, first one, if let's say I want to transform an alkene to an alkane, can anybody tell me what is the name of the reaction? Very good, thank you. Okay, hydrogenation reaction. What are the reactants required for hydrogenation? Tell me. Okay, hydrogen, good. Now, when I do hydrogenation reaction, hydrogen is one of the reactants. Is that a condition that I need? Phosphoric acid. Phosphoric acid, that one is for what? Phosphoric acid is for hydration. Okay, hydration. Okay, hydrogenation is with hydrogen as well as nickel catalyst and heat. These are the 3 conditions required. Okay, hydrogen, nickel catalyst, and heat. High temperature. Okay. So you need to know the temperature. Actually, you don't need to know. Your school teach you the temperature. Actually, you can write, you can don't write. You can just write heat, also can. Our level will accept. Okay, because based on syllabus document, you just need to know it needs to happen at high temperature. Exact temperature, you don't need to know. Okay? If your school teach you, then you just use the one that your school say easier as well. Okay. Now, question to you, or rather, let's write out how does hydrogenation actually works. Let's say I have an ethene molecule over here. I have C2H4. C2H4 over here. Now, I'm going to react with what? I'm going to react with 1 mole of hydrogen atoms. Now, hydrogen, I sometimes write H2, sometimes write H bond with H. Okay, both okay. But I want to show you how does the bond move. Hence, I want to show you the full structural formula. Now, look at this. These hydrogens over here, identify it. What is going to happen first step in any addition reaction is this. First step is you will break the double bond, one of the double bond. Now, when you break one of the double bond, can you see that each of the carbon atoms now have an electron to bond, to form a bond? Can, right? So with that understanding, now, look at this hydrogen. The next step is that I'm going to break this HH bond. The HH bond is undergoing breaking. After that, this hydrogen will come to here. Okay, this hydrogen will go to here. And then this hydrogen will come to here. Now, at the end of this, you need to see that they will form what? They will form an alkane molecule. This is the one. Okay. Now, I'm going to highlight the two hydrogen atoms that was added to the molecule. Can you see this is the hydrogen that was added and this one as well? Okay, so this is how does addition reaction work. Basically, I break the double bond, break the single bond, hydrogen atom comes here, the other hydrogen atom comes here. It forms what? It forms an alkane. Okay, so over here, this is an alkene. It forms an alkane. This is just a recap of all the reactions, okay? Okay, C9 questions. SAB says we don't need to get into detail for high temperature and pressure, so it's mentioning the nickel catalyst is a requirement. Yes, you need to know the catalyst. Okay, although you don't need to know what is the exact temperature, but nickel catalyst you need to know. Yeah. Okay, next. This is to convert from alkene to alkane. My next reaction will be what? My next reaction will be known as bromination reaction. This is another addition reaction. So all of these reactions are all addition. Addition means what? Addition means I have a new molecule, I add it to the alkene molecule, it forms me one single molecule. Basically, two molecules come together, become one molecule. This is known as an addition reaction. Can you see? Substitution reaction is what? If let's say I have a CH4, it reacts with Cl2, it will give me what? It will give me, it will give me CH3Cl plus HCl. Can you see? It is a substitution because there is no change to the number of reactants and products. Two reactants, two products. But for alkenes, can you see? There is two reactants. One is the alkene, one is hydrogen. The other one, it will form you alkane. One product only. Okay, come, let's look at this. Alkenes can also undergo bromination reaction. Same goes, let's draw in the ethene molecule over here. Okay, this time I will not draw the arrow. I think you understand already. Okay, it reacts with Br2. Now, bromination is what? With aqueous bromine. Okay, so what does it forms? Can you see that it will form a haloalkane? Okay, I will highlight the bromine atoms so that you can see where the bromine atoms go to. Okay. Yes, Ingrid, bromination cannot be used for alkanes. Bromination must be careful. Okay, everybody write down this one first. I explain to Ingrid. Now, alkanes reaction is what? Substitution with bromine, right? That one must be bromine gas. That one cannot be aqueous bromine. Sorry, forget something. Thank you for bringing this good point up. Later, I will go through. Yes, it will not decolorize, but to answer your question, it will not decolorize when we put aqueous bromine into alkanes. Okay, it will not decolorize. Okay, this one, everybody okay? Starting material is what? Starting material is an alkene. Okay. The end product is a dihaloalkane. What does dihaloalkane mean? Means there are two halogen on the alkane molecule. If let's say there's one Br and there's one H, this is a bromoalkane, right? Then if there's two, then it's a dibromoalkane. Remember? Can Okay, come back to the point on top. Sorry, keep scrolling. Okay, on top here, substitution with halogen. Now, can anybody tell me, this one I forgot. There is a special condition required for substitution with halogen. What is that special condition? For alkanes, substitution reaction. Yes, very good. You need the presence of UV light as well as the gaseous halogen, which means it must be gas state. Okay, no need high temperature, but UV light is enough. Okay, reason for UV light is so that it can overcome or rather break the covalent bonds in the halogen molecule. Okay. Elias says if alkanes can undergo bromination, can it react with other aqueous halogens as well? Okay, for your syllabus, you need to know it can react with bromine only. Can? Can If the question say, if the question need you to know that it reacts with something else, they will tell you. Okay, they will tell you, for example, alkene reacts with aqueous chlorine in a certain manner to form a product. Okay, for your syllabus, you need to know bromination only. Can Okay, next thing. Tell me, bromination reaction, is it important? If yes, type yes. If no, type no. If you say bromination reaction is important, why important? Aman, no. UV light is for substitution reaction. This one, no need UV light. This one just bromine water can already. Aqueous bromine. Yes, thank you, Hashim. It is to test whether it is an alkene. Yes, very good, Izati. It is to test whether something is saturated or not. So can you please put a big star over here? This reaction is super duper important because it is a distinguishing test. Okay, test for what? For unsaturated compound. There is one last one. Okay, so we cover three type of addition reaction. There are three addition reactions. You need to know. First is hydrogenation, which means I add in hydrogen. Second reaction is what? Bromination, means I add in bromine water, aqueous bromine. And the third one, okay, is known as hydration reaction. Now, when I say please hydrate yourself, means what? You drink water, right? You drink water, huh? Hydration reaction for alkenes is the same thing. They will drink water, okay? So hydration, you need H2O, okay? And for a special condition, this H2O must be a gaseous H2O, and you need H3PO4, phosphoric acid catalyst. Okay, you need H3PO4 catalyst. This is a hydration reaction, which means I am feeding water to the alkenes. Okay, same goes. Let's draw a molecule of alkenes first. I will show you how does the alkenes actually undergo hydration. Now, water molecule, remember how to draw H2O, right? Remember? Okay. First question. First step is always what? Break the double bonds. One bond broken. Second question, break one of the OH bond. Yes, Ingrid, correct. Okay, so we break these bonds, What happens next? Now, identify the two parts broken for here. There is one hydrogen atom, there is one OH. Now, this hydrogen will come to here. This OH will come to here. Can you see that? Can you see what is the product that's being formed? We just draw alkanes. Okay, hydrogen over here. This is the yellow color hydrogen that was added. Remember addition reaction, right? OH is over here. Now, first misconception of student. They always like to do this. The OH they put in the center like that. Then the teacher will see this and they will mark wrong. Why? Because whenever we are talking about bonds, they are only bonding from one atom to the other atom. You need to correctly identify which is the atom that is bonded to. So in this case, because I'm breaking this over here, there's one free electron, right? So this free electron can bond with the electron over here and this carbon. So that is how you need to know that the bond is from carbon to oxygen. Okay? Yes, Cheryl, yes. Okay, to form alcohol. Can So you realize something, this is an alkene. Okay, this is gaseous water, it is steam. What is going to happen? It will form a molecule of, what do you call this? Whenever there's OH group, we call this an alcohol. Okay, for combined science, you no need to know this reaction in particular, but it is good for you to know that alkenes can get into alcohol from this reaction. Why? Because your section B questions may either all questions may come out with this mechanism or this reaction. Okay, so it is not strictly stated in the syllabus, but is it good to know? Yes, it's good to know. Can I? Okay, so it forms us this new homologous series known as alcohol. Okay, alcohols. Okay, good. Thank you, Isati. Good. So next question. Alcohols, what? There are two ways for us to form alcohols. Alcohols are what? Alcohols are compounds that contain the formula CnH2n plus 1OH. This is the general formula for alcohols. Now, the functional group is important. You need to know that it is the OH group. Okay, this is the functional group. English name for this is known as the hydroxyl functional group. Okay, hydroxyl group. Okay, so this is for alcohol. Now, you need to know for alcohol, there are two ways for us to prepare the alcohol. The other way, okay, is known as fermentation. Yeah, right over here. The other way that you need to know is fermentation. Fermentation of glucose. Okay, to form alcohol. Okay. Now, there are two methods to produce alcohol. Number one, it is a hydration reaction of alkenes. Number two, it is a fermentation of glucose to form alcohol. Now, my question is this. Fermentation of glucose. What is the formula of glucose? Do you need to know? Answer is yes. Can anybody type to me? What is the formula of glucose? Chemical formula of glucose? C6H12O6. Okay, this one you must remember by heart. Glucose is C6H12OH. O6, sorry. Okay, so glucose, they will react with under a very specific condition. Can anybody type to me what is the specific condition? They will produce ethanol. Okay. Yeast. Okay, good. Yeast. What about it? What about yeast? Is there another certain specific condition it needs to have? Yeast cannot operate at too high temperature because it will die. Okay, so yes, correct. Everybody is correct. 37 degrees Celsius. Okay. Now, it will form ethanol and carbon dioxide gas. Okay. So ethanol is an aqueous, carbon dioxide is gas. Mole ratio is 2:2. Okay. 1 mole of glucose produces 2 moles of ethanol and 2 moles of carbon dioxide. Now, yes, important. Mukundan says absence of oxygen. Yes, that cannot have oxygen, so it must have absence of oxygen. The condition is simple. Okay, absence of oxygen. Reason why there is an absence of oxygen, because ethanol can oxidize to form carboxylic acid, and I don't want this to happen. So hence, I need to have absence of oxygen. Now, in exam, they might ask you a question. Why is it that through fermentation process, we cannot produce alcohol that is more than 14 to 15%? Okay. Why is it that through fermentation reactions, we cannot produce? Yes, the yeast will get denatured. So the question is this, common exam question. Oops. Okay, write this down, common question. Why is it that? Why cannot produce alcohol more than 14 to 15%? Okay, answer is this. Okay. When the percentage of alcohol, okay, exceed 15%, what happens? The yeast is denatured. Okay, the yeast is denatured. Hence, therefore, we cannot increase the concentration. The concentration. Okay, can okay, so this is a common exam questions as well. Okay, good. So this is my second way of forming alcohol. So there are two ways. One is the hydration reaction of alkenes. Second way is fermentation of glucose. Okay. Now, my next question to everybody after you have finished copying is alcohol acidic or alkaline? Some students tell me, okay, there's an OH group, means it's acidic. But it's just neutral, okay? Neutral. Says alkaline. Yes, Aman, correct. Okay, is presence, okay, as a catalyst for the reactions. It helps to break down the glucose molecule. Yes, Ingrid, correct. Okay, you're always one step ahead. Just now we're talking about hydration reaction. Now you're talking about oxidation. Okay, good. Depends the length of carbon to carbon bond. Sinan says alcohol is acidic. Okay, actually, important thing for you to know. Ethanol or alcohols, in fact, alcohols are all neutral. They are all neutral. Okay, this neutral means what? Means most of the time it is pH close to 7. Okay, pH close to 7. Now, reason for this, okay, reason for this is simple. Students tell me, because there is this OH group, means it will dissociate in water to form OH minus. Is it correct? No, answer is no. Because this OH is not OH minus. It is not OH minus. Okay, I will draw out for you. I will draw out a molecule of alcohol for you. Okay, let's draw a very simple alcohol, methanoic acid. 1 carbon, alcohol. Now, can you see something? This group over here, the OH group, these are all covalent bonds. These are all covalent bonds. Okay. When there is these covalent bonds over here, what do you identify or what can you conclude is that this OH group is not the same as OH minus. When OH minus comes about, there should be a negative charge and positive charge. There should be ions. Okay. There should be ions. Okay. Can Okay, although your answer is correct, but because most of the students here are taking O-level, they do not cover hydrogen bonding. Okay, so for you, I think because you are IB, right? IB student, okay, your concept may be slightly different. Okay, or for students, most of us, okay, we learn for the O-level students, okay, most of us over here are O-level student, right? Okay, or actually all of us are, except for a few. Okay, this OH group is not the same as OH minus. Okay, hence, you need to understand that alcohol is neutral. Okay, alcohol is neutral. Alcohol is neutral. Okay, with that understanding, now we are going to look at reactions of alcohols. Okay, see, we go from first homologous series alkanes, we come down to alkenes. Now we talk about alcohols. Okay, now alcohols, what kind of reactions can they undergo? Type to me inside the chat. Okay, yes, okay, Ingrid, you're right. It can undergo oxidation reaction. Melissa, you're right. Okay, undergo combustion reaction. Good. Okay, so first thing to settle, it can undergo combustion reaction. Combustion reaction. Okay, I'll draw an arrow upwards. It can undergo combustion reaction as well. Okay, first type of reactions. Now, second reaction is known as oxidation reaction. Okay, now alcohols, because of the nature of it containing an OH group, it can undergo oxidation reactions. Now, let me just draw an arrow over here. Okay, I will write down the fact that alcohols, they can undergo oxidation reactions. Now, remember, oxidation is what? Oxidation is, in terms of hydrogen and oxygen, oxidation is a gain of oxygen atom. Okay, loss of hydrogen atoms, right? This one is the concept of oxidation. We bring in redox. Okay, yesterday's lesson on redox reactions. Okay, gain oxygen atom, lose hydrogen atoms. So this concept over here will manifest itself in terms of how does an ethanol molecule forms an acid. Okay, oxidation reactions of ethanol, they will form me a new functional group or new homologous series known as acid. Okay, Izati asks, why is it combustion and oxidation both requires heat? Can't both be combustion. Combustion is when you burn in air, burn in oxygen. Okay, oxidation is not. Okay, oxidation is a very controlled reaction. I am trying to supply more oxygen atom into the molecule. Okay, combustion is to break down it into its constituent element, which means that combustion will produce what? Okay, let's say I'm going to combust CH3OH. If I'm going to undergo combustion of this material, this one is going to undergo combustion. The equation going to look something like this. CH3OH going to react with what? O2 to form what? To form carbon dioxide as well as water. Okay, this is the complete combustion. Now, if I want to balance the equation, can you see how many oxygen atoms are there over here? Okay, I have 3 oxygen atoms and I have 4 water molecule, right? So this O2 will comes to here, J2 so I need 2 molecule of CH3OH. Okay, so I have 2 CO2. Okay, what happens? I have H4O. Okay, I should have 2 of these as well. And 2, oops. How many oxygen I should have 3. Okay, we have 3 oxygen. All right. Total, I should have this as my equation for combustion. Alcohol can go through combustion, yes. Okay, react with oxygen at very, very high temperature, it can undergo combustion reaction. So all of the 3 alkanes, alkenes, and alcohols, they can all undergo combustion reaction. These are the 3 functional group, homologous series that can undergo combustion reaction. Okay, okay, so this one you need to supply a lot of heat. Okay. Next, oxidation reactions. If let's say I have a ethanoic acid, ethanol is 2 carbon, right? C2, H5, alcohol, so it's OH group. Okay, this is ethanol molecule. Now, when we undergo oxidation, that means what? I need to remove hydrogen atoms. I need to gain oxygen atoms, right? Remember? So oxidation, because we are not using oxygen gas, I will write this form. I will write in this form plus O. Like that, square bracket O. Square bracket O represent an oxygen atom that is supplied by an oxidizing agent. Okay, later we will discuss how does it works. I will supply, this is, okay, I just put a note over here. These are oxygen atoms supplied by an oxidizing agent. Okay. Okay, Hashim is not O2 because this reaction, oxidation reaction, it does not happen with atmospheric oxygen. It does not happen with oxygen in the air. This one is the strong oxidation that we are talking about. We are using a strong oxidizing agent. Okay, yes, you are right. KMNO4, correct. Okay. Can Okay, so I write a plus O over here and it will give us what? Okay, how does oxidation reaction works? I will tell you very quickly. Identify over here on the ethanol molecule, these 2 hydrogen, I highlight these 2 hydrogen. Now, remind yourself, these 2 hydrogen will be removed. Remember, oxidation is what? Gain of oxygen atoms, loss of hydrogen atom, right? So they will remove these 2. Okay. Now, this part of the molecule over here, there will be no change. That means what? Safe to say, I can draw in the same molecule over here. The first part of the molecule is the same. Second part of the molecule, I have a carbon and the OH over here. There is no change. Now, in place of the 2 removed hydrogen atoms, what do I do? Because you remember it is a loss of hydrogen, gain of oxygen, what is going to happen to this carbon is that it is going to form a new double bond with an oxygen atom. This is where the oxygen atom comes into play. The oxygen atom will come here to this carbon and forms a double bond. Any questions so far? Can I form a double bond? Now, this double bond over here, what is going to happen to it? and it's going to form a double bond with the carbon atom, and you will realize, okay, that this group stays here. This group is the same group as just now. You will realize that it forms this new functional group over here. And this functional group is none other than the COOH functional group. This is known as the carboxyl functional group. Like carboxylic acid, okay, carboxyl group. Okay, and what is the byproduct of this reaction? Can you see, because I remove these hydrogens, it need to form what? It need to form water because it reacts with oxygen. 2 moles of hydrogen react 1 mole of oxygen to form UH2O. Okay. Can you see this is how an oxidation reaction works? I will put a square on this. Yeah, box this out so that you know. Okay, this is our oxidation reaction. Now, the reagent for this reaction, you need to be aware that it requires this thing. Okay, reagent is a strong oxidizing agent. In our syllabus, we learn what as a strong oxidizing agent? Potassium manganate, right? Aqueous acidify. Okay, heat. This is the reactions, reagent and conditions. Yes, Jingwen, you are right. Okay, oxidation forms carboxylic acid from water and from oxygen and alcohol. Okay, so this is a carboxylic acid. Okay, remember, carboxylic acid contains this functional group COOH, C double one O and OH. Okay, now this is the first type of reaction, first type of oxidation reaction. Now, like that, using a strong oxidizing agent like acidified potassium manganate, what it's going to do, it is going to force oxygen atoms into the molecule, and it's going to force hydrogen atoms to be removed out of the molecule. That is the job of the oxidizing agent. Try and snatch away all the hydrogen, okay, and supply as many oxygen atoms to the molecule as possible. So in this case, they supply them 1 oxygen molecule, and 1 oxygen atom, and take away 2 hydrogen atoms. Okay, so over here, this O, what is the coefficient? Is it 1? Is it 2? Is it 3? Yes, Aman, we are now balancing. Balancing using the square bracket O. Is it 1, 2, or 3? Look carefully. I'm adding 1 oxygen atom here. Okay, it's a square bracket O. And remember, the job of the KMnO4 is to snatch all of the hydrogen away. So when they snatch all the hydrogen away, they form what? They form water. Can you see water also have 1 oxygen atom? This oxygen atom come from where? From here lah. Huh? Answer for this coefficient is 2. Okay. Aqueous acidified potassium manganate over here cannot put O2. Cannot. Why? Because aqueous potassium manganate, aqueous acidified potassium manganate don't have O2. It only gives you oxygen atoms in terms of an oxidizing agent. Any question? Okay, if no question, can you give me a thumbs? Okay, thank you, Izati. Thank you, Ingrid. Thank you, Melissa. Okay, good. Kaiti, Rachel, Cheryl, any questions? Yes, good. Okay, that's the next part that I want to go into. Okay. Yes, Sinan. So you need to put 2 square bracket O. The square bracket represent it is an atom. It is an atom that is going to be added by an oxidizing agent. Okay. Now, when I'm using a strong oxidizing agent like potassium manganate, the color of it is purple. After the oxidation process, what happens? This thing already gets reduced, right? Oxidizing agents get reduced, right? After potassium manganate reduced to form from MnO4 minus to Mn2 plus, there's a decrease in oxidation state. What happened? The color observation, you will realize that, oops. Okay, the color will be from purple, KMNO4, turn colorless. Tell you a story. Okay, so today I drink wine. I have a glass of wine over here. I drink already, I drink halfway, then I fall asleep. Tomorrow morning I come back, I drink the wine. Suddenly the wine turns sour. Tastes sour. Why is it? Why is it that the wine will taste sour? Okay. This is because this reaction has also occurred. Then you ask me, how come I never put potassium manganate into my wine? Why is it? Wine contain alcohol, right? Wine contain ethanol, right? Okay, but why is it that, but I never put potassium manganate? Why is it that it will turn sour? Because it's still from carboxylic acid, right? Yes, okay. Izati is right, okay? Oxidation can occur when there is atmospheric oxygen. So this is the second set of reagents. It's a either or, okay? Atmospheric oxygen in the air, okay? Yeah, oxygen that's in the air lah. Huh? So what happened? Yeah, I cannot drink because why? Now I'm drinking acid. Instead of drinking my nice, smooth wine, now it become acid. Yeah, like sour. Huh? So you cannot, moral of the story, if you drink wine, you are all underage, so no. But anyway, if you drink alcoholic beverage, don't put outside for too long because it will turn sour, turn to form acids. Can? Okay. Now, then I got a question. Let's say I'm a company who want to manufacture carboxylic acid to supply to maybe like school lab, your O level, right? Why is it that if I am a company, if I get ethanol, I want to choose number one instead of number two? Why is it that I don't just leave the ethanol there, then let it slowly oxidize? Why do I want to use a strong oxidizing agent? Yes, correct, faster. Yes, very controlled. Yes, faster. Okay. So this process is fast and this process is slow. Okay. Now, most of the time, they will not ask you to write an equation for this. But in the event that they ask you to write equation, what happened? You need to write with O2. Because in this case, oxygen is no longer supplied in terms of atoms, but it is supplied in terms of a molecule of oxygen in the air. Can oxygen in the atmosphere is O2. Yes, correct. Okay, thank you, Sinan. Okay. So it's a slow reaction. So if let's say the question say I want a fast reaction, choose number one. If they want slow one, choose number two. Most of the time, they'll ask you to do one because they want you to be able to know how to write this. Can? Okay 可以嘛 Everybody okay Okay, good. So this is the oxidation reactions of alcohols, and it forms us these new homologous series known as carboxylic acids. Okay, so I'm going to draw an arrow over here. Okay, zoom out a little bit in case you are still copying. Anybody still copying. Okay, over here, this new homologous series is known as carboxylic acids. Aman, no need. Just need to say atmospheric oxygen is okay. And O2 in the air is enough already. Okay, now carboxylic acid is the last homologous series that we learned. Now this is the special one, okay, because this one has different reaction or it has interesting reactions. Now, carboxylic acid, yes, very good. Thank you, Jingwen. Before if I even ask you, already tell me. Okay, general formula is CnH2n plus 1 COOH. Okay, this is the general formula. Now, this is the functional group. COOH is the functional group. It looks like this. It looks like this. Please go and remember how to draw this. Okay, please go and remember how to draw this. This is super important because when exam give you a molecule that looks like this, then after that, all the students will start, what is CO2H? What is CO2H? What is this? How does the thing draw? Then they will start drawing funny thing like this. Okay, please don't. Okay, CO2H or COOH simply means it's a carboxyl group. Okay, carboxyl group. Now, my next question to you is this. Why do we then call it carboxylic acid? Okay, it needs to be acidic lah, obviously, because the name of carboxylic acid definitely comes from the fact that it will produce what? Acid produce what? Can anybody tell me? Remember acid and bases. Acids will produce what when dissolved in water? Very good, very good. Thank you, everyone. H plus ions in water. Okay, H plus ions in water. Okay, that means carboxylic acid, okay, it is a weak acid. Okay, now why is it not a strong acid? All organic acids are weak acids because organic stuff are more natural. Natural one normally is not so harsh one. Okay, mineral acid like HCl, H2SO4, those are strong acids. But organic acid is a weak acid, and okay, they produce a low concentration of H plus when in water. Okay, so I'm going to write out the dissociation process of how does a carboxylic acid dissolve in water to form H plus. Okay, look at this carefully. Now, if I use ethanoic acid as an example, CH3COOH, let me just draw the full structural formula out. Now, my advice to you is please be very confident in drawing structural formula or display formula. Okay, display formula is important for you to know. Because when you draw display formula, all the bonds you can see. And most of us, we are all visual learners. Humans are all visual learners. That means when we see how does the atom move, for example, just now I teach you about bromination, how does the bromine atom move, right? You will be able to understand better. Okay, so in the event, not just for learning sake, in exam, if let's say you think that drawing will help you, okay, try and draw the molecule out as well. Okay, now this is a molecule of what? This is a molecule of ethanoic acid. Now, when I throw this molecule in water, what is going to happen? It is undergoing dissociation. It's going to ionize to form H plus. Okay. Now, important thing for you to know, for carboxylic acid, the H plus that is going to give the molecule the acidic property is this hydrogen over here. You must remember this. This is the hydrogen that is going to give you the acidic property. And some of the time, or most of the time, I call this the acidic H plus. Okay, this is the acidic hydrogen. This is the one that will give you the H plus. The rest of the hydrogen, they will not give you H plus. Okay? The rest of this hydrogen, it will not give you H plus. If not, let's say I put methane into water, then suddenly all of the hydrogen will become H plus. Then my C will have a 4 minus. Because all of it become H plus, H plus, H plus. Okay, cannot happen, right? So this is not possible. So all of these, okay, please go and write down over here somewhere. All these ions, all these hydrogen, okay, do not form H plus. Okay. So what is the outcome that you will have? You will see something like this. Okay, draw the same structure except for the hydrogen, the oxygen over here. Now, if this hydrogen take away a plus charge, what must happen to the oxygen? What charge does it have? Type to me in the chat. Anybody know? I say again, OH bond, hydrogen take away a positive charge. Oxygen must have, yes, very good. Thank you, Sinan. Thank you, Ingrid. It must have a negative charge. Okay, this oxygen must have a negative charge. This hydrogen must have a positive charge. Okay, this is the same as how does HCl dissolve in water. It gives a H plus plus a Cl minus. Okay, same principle. Now, important thing to highlight is this. It must be a reversible reaction. Why? Because this is a weak acid. Weak acid reversible reaction. Can Now, this is known as ethanoic acid. The corresponding negative ion, it has a special name. This is known as the ethanoate ion. Ethanoic acid, ethanoate ion. Okay, carboxylic acid, carboxylate ion. Can This one got no special name lah. This one is just hydrogen ion. Okay, same goes for whatever that we studied previously. Okay, so this is how does carboxylic acid exhibit its acidic properties. Can ah? Okay. Okay, good. With that understanding, okay, I'm going to look at reactions of carboxylic acids. Yes, ingredient later. Okay. Well, you always one step ahead, as mentioned just now. Yes, we are going to cover ester also. Okay. Can ah? All right. Okay. So carboxylic acid, first thing to note, because it is acidic, it is going to react with what? If you are my student, can you type in the 4-letter acronym that I tell you? Okay, don't the 4-letter acronym don't start with F one, start with A one. Yes, very good. Thank you, Melissa. Okay. Very good. Okay. So acronym is ABCM. So that means what? Because it is an acid react with ABCM. Now, what is this ABCM? A stand for alkali, B stand for base, C stand for carbonate, and M stand for metal. These are the 4 reactants that acid react with. Okay, remember acid plus base give you salt and water, alkali give you salt and water, carbonate give you salt, water, carbon dioxide gas, and metal give you hydrogen gas and salt. Okay, remember this. Okay, your product is always going to be salt plus something else. Okay, whether is it water, water plus carbon dioxide plus hydrogen, etc. Okay, you will always have this. So, because it is a carboxylic acid, you will obtain something known as the carboxylate salt. Okay, so for example, sodium hydroxide react with ethanoic acid, you will get something known as sodium ethanoate. Okay, basically it is the anion. For example, sodium chloride, right? Chloride is the negative ion, right? Because now it is an ethanoic ion, hence we call it sodium ethanoate. Can ah? Okay, with that understanding up to here, any question? If no question, can you give me a thumbs up? Yeah, if no question, thank you, Kai Chi, thank you, Izati, thank you, Ingrid, thank you. Okay, good, thank you, Chloe. Now, for combined chem student, can you try question number 1? Pure chem student, you stay with me. Because pure chem, you learn esterification. Combined chem don't learn. Okay, so combined chem student, can you try question 1? After I finish covering esterification, I will proceed on, okay, to question number 1. Okay, so carboxylic acid, this is the first type of reaction. It reacts with ABCM. Now, the second reaction of carboxylic acid is as such. Second reaction, this is known as a esterification reaction. Now, can you tell me anybody? Esterification reactions involve what? Which 2 homologous series? Very good. Thank you, Ingrid. Okay. Alcohol react with carboxylic acid. Okay, alcohol plus carboxylic acid. Now, with this understanding, what I want you to do is very simple. If let's say I give you an example, I give you metanoic acid. What is metanoic acid? Metanoic acid is 1 carbon carboxylic acid. Look like this. HCOOH. This is metanoic acid. Now, if I react this with ethanol, okay, react this with ethanol. Now, whenever we are doing esterification, I want you to be very careful. When the alcohol and the carboxylic acid, okay, maybe I do in alcohol and carboxylic acid. Don't do the other way around. Okay, ethanol first. CH3COH. Sorry, CH3OH. That's methanol. CH3CH2OH. That is ethanol, right? So let's draw in ethanol first. Sorry, I confused with a lot of organic compound. Okay, CH3CH2OH. This is C2H5OH. This is alcohol. Okay, molecule over here is ethanol. Now, I'm going to react it with metanoic acid. Metanoic acid is HCOOH. Okay, this is metanoic acid. 1 carbon carboxylic acid. Give us what? Can anybody tell me? Give us what? Does it give me methyl ethanoate or ethyl methanoate? Okay, says ethyl methanoate. Okay. Anybody say methyl ethanoate? Yeah. Okay. Esterification is a reversible reaction. Okay, you need to put this. Okay, English say ethyl methanoate. Okay, good. Now, so how does esterification reaction go? First question is this. Esterification, it requires this condition. I will write down the condition for you. Esterification with a few drops of concentrated sulfuric acid, concentrated H2SO4. This is the condition. It needs few drops of concentrated H2SO4. Now, what is the job of a concentrated H2SO4? It is a dehydrating agent. What does a dehydrating agent do? It removes all the traces of water for this reaction. Okay, that means what? Can you see ethanol and methanoic acid? If I draw it like that, one of the things that I want you to remember is this. When you draw the ethanol and methanoic acid side by side, what I want you to do is not like that. It's actually to put both the OH side by side. Means what? That means, oops, that means I will draw like that. H, C, O, O, H. I draw from right to left. Okay, Ingrid, wait a moment. I will explain this. Okay, first thing to do, put the two OH groups together. One is the COOH, put it next to the OH group of the alcohol. Now, that's where H2SO4 comes into the picture. Okay, look at this carefully. This is the ethanol, this is the acid. Alcohol, the acid. Water is going to be removed, dehydrating agent. Just now I say hydration reaction, I let you drink water, right? Dehydrating agent means what? I drain the water from you. I take out water from you. Look at this. From the alcohol, alcohol is the poorer one because it doesn't have a double bond O. So I will just take the hydrogen for alcohol. Then who is the richer one? The acid, definitely the richer one, right? Okay, so I'm going to take the OH from the acid. Circle these two. Circle the hydrogen from the alcohol and circle the OH group from the acid. These two, we will have it circled. Next thing to do, draw an arrow. Tell yourself this one will be removed as H2O. Okay, remove a H2O. Now, next thing. Once I remove this as H2O, definitely one of the product that you will get is water. Definitely. Okay. What happens after I remove H2O is this. This carbon over here will connect a covalent bond to this oxygen. Can you see? Because the water molecule is removed already. So same goes, I will draw whatever that is on the left, which is this. Okay. Same structure, hydrogen, carbon, oxygen, hydrogen on top and below. The covalent bond will be drawn to carbon, whereby there is a carbon bond with oxygen and hydrogen. Do you need to draw this super long? No need. I'm just drawing here for illustration purpose. Okay, that these two bonds are actually connected together now. Okay, so on the left-hand side, it is where your alcohol was from, and on the right-hand side is where the acid is from. Can you see that? Okay, because there is a dehydrating agent that removes traces of water from the ethanol and acid, this is what is going to happen. This is the ester that is formed. Okay, can then after that you will call this, okay, the ester linkage or the ester bond, whichever your school use, ester linkage. Okay. Now, naming of esters. Naming of esters, always use this acronym ABC. Alcohol before carboxylic acid. Alcohol is what? Ethanol, right? So it will be ethyl. Carboxylic acid is what? Methanoic acid, right? Methanoate. Okay? Alcohol before carboxylic acid. Alcohol first, then carboxylic acid. Okay, so this will be the name for this ester over here. Any question? If no question, can you give me a thumbs up? Okay, thank you, Ingrid. Thank you, Melissa. Okay, thank you, Chloe. Yeah, everyone okay? Okay, good. Thank you, Kaisi. Now, with that, this is the end of our mind maps today, right? Can you see that we summarize all of organic compounds into one mind map? That's it. Finish. End of story. No more already. Okay. So actually quite simple. It's just on one page. But although we take around 1 hour 20 minutes to do this lah. Okay. So in exam, please have an idea of what is going on for all of this. All right. Thank you for the emoji. Ingrid, you put the celebratory emoji, right? Okay. Thank you so much. Saw that. Okay. The LCP is not in O level. Okay, so don't need to mention that. I know you are from IB lah. Okay, so if you have any question with that, yeah, I can answer. I'll be happy to answer them later. I zoom out, huh? I zoom out will be too small or not? Ash, I zoom out, is it too small? Oh, okay. Okay, now, later, right? Later on, okay, please have a copy of this summary. Okay. Now later I will tell you something. We have a giveaway later. So okay, can just for your information. Okay, so shall we try some question first? We have around 40 minutes remaining. Let's try some question. Okay, I'll go through question one with you, and the rest of the question we will attempt them step by step. Okay, I've also included some of the revision question. So later one of the questions we will designate it as a revision, so you can go home and do yourself lah. Okay, if you need the answer, you can let me know. Now let's look at question number one. Now using the knowledge that we have acquired just now in the mind map. Okay, let's look at this. In question one, boiling points of ethane and some chlorine-containing organic compounds are given. So can you see? We have ethane, then we have C2H5Cl. This is a mono substituted. Can you see? These are all substitution reaction. When I have an alkane, I undergo one-time substitution. After I get C2H5, I undergo another one. So this is a di substitution. 2 times, so this is 2 chlorine atom. I will undergo one more time of substitution reaction. This is a tri-substitution, and so on and so forth. And then there's a quadruple substitution, right? So what is the general trend in terms of boiling point? Okay, can you see that because from C2H6 onwards, there is a steady increase in boiling point, right? So we can say that as the number of chlorine atoms in the compound increases, okay, increases, okay, the boiling point increases. So general trend, you must take note of this. You will need to tell them what is the factor, what is the outcome, what is the cause, what is the effect. Okay, question B part 1, very simple. What is a hydrocarbon? Hydrocarbon means what? There is hydrogen and carbon only in the atom. Only got hydrogen and carbon, C2H6. Okay. Next one, which compound belong to the same homologous series as C4H8Cl2? Homologous series means what? Means a family of organic compounds. Okay, same homologous series as C4H8Cl2. Okay, same homologous series as C4H8Cl2. Okay, so in this case, this compound itself have what? C4H8. Okay, so 4 carbon atom. H8. 1, 2, 3, 4, 5, 6, 7, 8. And 2 chlorine atoms. Okay, same homologous series as Cl2. Sorry, C4H8Cl2. So how to find homologous series for this case? They are saying what? C4H8. Anybody have answer for this? Part 2. C4H8Cl2. Okay, general formula. Okay, come. So you can see that they're talking about all containing compounds, all compounds that containing 2 chlorine atom. Okay, so in this case, answer should be C2H4Cl2. Okay, homologous series. Can you see? Because this is what? C4H8 ma. Okay, CnH2n ma. Okay, then in this case, this is Cl2. Okay, so it's C2H4, Cl2. Okay, basically they ask you to identify the compounds that have CnH2n, Cl2. Can ask you to identify the general formula. Okay, okay. Homologous series are in green. They ask you to explain, or rather they ask you to find what is the general formula, right? In this case, C4HACl2, you can put as CnH2n because I don't want to put Cln. Normally, Cl is either Cl or what. But in this case, there's two, right? So I just put two over here. So I go up there, I match any of them that follow this. Okay, can you see which one follows Cl2? C2H4Cl2. Okay, this one is the answer. Can yeah. Okay, next. State the total number of compounds in table 2.1 which are soluble in organic solvent. What kind of organic compound are soluble in organic solvent? All lah. Okay, 1, 2, 3, 4, 5, 6. Okay, all of the time organic compounds, alkenes are soluble in organic. Okay, so 5. Okay, isomer. Isomer is what? Remember isomer we talk about what? Same molecular formula, different structure. A different structure means the layout of the atoms. Oops. Hey, C2H4Cl2. My advice to you, everybody, when you are drawing isomer, you will always follow this. You first draw the carbon backbone first. Next, if they ask you to draw chlorine, okay, you will need to be able to draw in the chlorine atoms. If let's say I draw both of them in one, okay, then the rest I fill in with hydrogen atoms. Okay? Can Okay. Next question. This is one isomer. Okay, this one isomer. The other isomer is as such. How do you draw the other isomer? The other isomer will look something like this. Now, this is on carbon number 1, carbon number 2. If I draw the 2 carbons again, then if that's the case, I will put all of the chlorine on carbon number 1, all of the hydrogen on carbon number 2. Okay, these two are 2 different isomers. Can you see? 1 and 2. Okay, for pure chem only. Combined chem no need to know about the isomer. Don't need to know how to draw the isomer. Can Okay, so basically, can you see carbon number 1 have 1 chlorine, carbon number 2 have 1 chlorine. This is the first isomer. Second isomer is whereby, okay, the carbon atom number 1 have both the chlorine atoms. Can Okay, so this is the isomer. Any question for question number 1? Okay, Okay, let's go next question. Now, question number 2, they tell us that kerosene can be broken down into simple hydrocarbon by passing it over a powdered catalyst of alumina. Okay, alumina is aluminum oxide. Okay, and silica. Silica is silicon dioxide. Okay, before that, Arman says, how many isomer possible? Anybody can reply to Arman's question. How many possible isomer is there for this compound? Melissa said 3, Elias said 2. Kaiji said 2. Okay, good. Answer is 2. Reason for it is simple. Can you see this Cl and hydrogen? They are the same. You can see that this carbon atom, these 3, they can change position. When they change position, it does not change anything. So if I say I put the chlorine here, it's the same as me putting the chlorine here. Why? Because these things, remember, I draw like that is flat on paper, right? But if actually it is in real life, right, it looks something like what we call a tetrahedral arrangement like that. C, H, 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 like that. Can you see? So all the 3 are the same one because this one can rotate. Okay, this is a 3D arrangement. Can you see? They are all like standing like that. They can rotate one. Okay. So this one is one isomer. Then the other isomer is where the two chlorine atoms are on the single carbon atom. Okay, then the other side is as such. Same. Okay, okay, next. Alumina is aluminum oxide, silica is silicon dioxide, okay, as shown. When E reacts with bromine, it forms a dibromo alkane. Okay, it forms a dibromo alkane. Can anybody tell me E must be what homologous series? E must be what homologous series? Alkane. When E react with bromine, it forms a dibromo alkane. Okay, never mind. Before that, we do some math first. Whenever we are doing cracking, can you see? This is a cracking reaction. I have a big hydrocarbon become a small hydrocarbon. I will take this 14 minus the 6 minus the 5. 14 minus 6 minus 5 give you what? Number of carbon for E. This will be C3. Am I right? 3 plus 5 plus 6 give you 14. Yes. This 30 minus 10 minus 14. 30 minus 10 minus 14. It will give you H6. Answer for this, it follows CnH2n is an alkene. So you need to identify this is an alkene. Now, bromine, this is a bromination reaction, forms a dibromo alkane. Okay, C3H6 forms a dibromo alkane. Now, question is this: identify which compound is formed from E and hence deduce the identity of E. They give you 1, 2, and 3. Okay, identify which is the one. Explain reasoning and describe the reaction that takes place to produce dibromo alkane. Okay, now simple. C3H6, how to draw? I will draw it like that. C, C, C. This carbon, because carbon can form 4 bonds, there will be 3 hydrogen over here. This carbon have 1 hydrogen and it finished 4 bonds already. This hydrogen over here, there is 1 hydrogen, 1 hydrogen. Now, next question is, I have Br2, Br, react with aqueous bromine. First step always is to break apart the two items. One is the double bond, one is a Br bond. Okay, finish. Erase this bond, remove this bond. Next, identify the fact that this carbon atom as well as this carbon atom can receive a bromine. So, chuck the bromine into here, chuck this bromine into here, and forms a single bond over here. Now, look at this article. Follow. Is there any molecular formula that follows this one? Look at the first one. Br, CH2, 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 Br. Is it correct? No. Because we look at this. This one is Br, CH2, Br, CH. Okay, as well as CH3. This is what it looks like. Okay, sorry, should be CHBr. Oops, CHBr, because the bromine is attached to the carbon. Okay, bromine is attached. Okay, so we always go left to right. C, H2, the Br first, CH2, CH, Br, CH3. Okay, we always go left to right. Okay, in terms of writing molecular formula, remember this. Now, look at this formula. Which one does it tally? Does it tell you number 1? No, because the Br is at the end. Answer number 1 wrong. 2, I have CH3, CHBr, CH2, Br. Okay, so basically this formula, if I invert it around, if I turn the molecule like that, you will realize that it gives you molecular formula number 2. Then correct. This one, CH3, CH2, CHBr, 2. Is it correct? Bromine is on 2 different carbon atoms. So answer for 3, wrong. Okay, so I help you to by the process of elimination and visualization, you can get the correct answer. Okay, easy. Okay, so which is the one? Compound number 2, CH3, CHBr, CH2, Br. Can explain a reasoning. Okay, hence due to the identity of E, E is C3H6. Okay, E is C3H6. But they say what? They want the identity of E. Identity of E means you need to write. Okay, you need to write. Okay, so E is propene. Okay, you cannot give molecular formula because molecular formula don't give you the identity. Identity is when you need to show the bond. All right. Okay, E is propene, or you give them the full name. Okay, chemical name. All right. Okay, so then they ask you describe the reaction that it takes to produce dibromo alkane. Okay, so E undergoes Undergoes what? Addition reaction, okay, with Br2 to form dibromoalkane, okay, where each of the adjacent carbon atom has one new bromine atom attached. Okay, can you see? The two adjacent carbon atoms, the one side by side to each other, they have one new bromine atom attached to it. Can Okay. Now, if let's say you find it too difficult to explain in words, if you want to write down the molecular equation, okay, you can do that. Okay, it means you put down the structure inside here. Can Hashim, can you just say it's an alkene? No, alkene is a homologous series. Okay, that one is to identify the homologous series. But to identify the alkene directly, you need to tell them the identity, which means what molecule is it. For example, I ask you, can you identify yourself? Okay, I say my name is Hashim. I cannot say I'm a human, ma. I'm a human. Everybody is human, ma. That one is a general description, right? Okay, okay. Part 2. E is subjected to high temperature and pressure. It forms a polymeric material that is used to make disposable container. Okay, come. Now, this part about polymerization, very quickly, I will go through with everyone. This one is applicable for both pure and combined. Okay, polymerization of alkenes. Alkenes polymer. Okay, E is propene. Now, first step always, can my student tell me what is the process for polymerization? Always first step, what do I do? Or anybody, what is the first step when we undergo polymerization? What do I do? Very good, thank you, Kai Chi. Write in the H structure, then break the carbon to carbon double bond. Very good. Okay. First step is always to redraw the monomer in H structure. What do I mean by that? Can you see C3H6? When you draw out, it looks something like this, right? C3H6. Okay, don't draw this one. When you do polymerization, I want you to be very careful. Answer. Sorry, this one is wrong. Okay, it's like that. You should redraw in terms of the H structure. That means what? CC double bond. Anything else must go up or come down. Look at this carbon. They have a CH3 over here, right? CH3 over here. So CH3 cannot be to the left. It must go up. Okay, so hence this one go up, CH3. This hydrogen over here, okay, can either come down or it can go up also lah. Basically, if I put the CH3 down, then I put the hydrogen on top. No? Both ways, okay. Either one is acceptable. Over here, this carbon, very simple. This carbon over here, one hydrogen up, one hydrogen below. This is the H structure. This is the monomer in the H structure. Once I have that done, erase everything else. Now, this is your monomer. They ask you to find what is the repeating unit of the polymer. Second step, break the double bond. Okay, break one of the carbon to carbon double bond. Okay. Then you draw the two arms that connect here like that. Can so this over here is a repeating unit like that. This is a repeating unit of the polymer. Can you see that as the polymer go on, there will be another CH3, CH over here, CH2 over here, like that. It will continue on and on. Okay, so this is how polymerization actually happen. Okay. Yeah, give me a moment. Okay, come. And you explain the CH3 part again, please. Okay, can. Look at this. Okay, I draw for you at the side. C3H6, it looks like this. C3H6. any problem with this. I think everybody is able to get this. No problem, right? I want to draw in terms of a H structure. Can you see the H need to look like this? The double bond must be in the center of the H. Okay, so in that case, I need to bring this whole part inside below. So I remove this group. I condense, I write below as a CH3. Understand? Can okay, thank you. Okay, good. Next, state one possible environmental consequence of using a polymeric material. In this case, what is a consequence of using polymer, a plastic? Okay, number one, you can tell them maybe land pollution. Okay, plastic is non-biodegradable. Non-biodegradable. Ingrid, your ya means what? You need me to explain any part of the question again? Oh, no need. Okay, can. Okay, good. Then second one is what? If let's say I burn the plastic, cause what? Air pollution. Okay. Burning of plastic. Yes, very good. Thank you, Jingwen. Produce toxic gases. Okay. Another one, since air, land, the other one is what? Water, right? So water pollution. Okay. Maybe marine life, like your turtles, okay. Okay, may be endangered due to plastic waste. Okay. Uh, or slash being trapped in plastic bag, etc. Bottles, bags, etc. Okay, marine animals. Yeah, same thing. Marine life and marine animals. So just one possible environmental consequence. So if you cannot think of any environmental consequence, always think along the three lines. One is air, land, and water. Okay. Okay, up to here, any question? If no question, can you give me a thumbs up so I know that we are okay to move on? Okay, thank you, Jingwen. Thank you, Melissa. Okay, thank you, Aman. Thank you, Ingrid. Okay, good. Let's go to the next question. If you need time to copy, please let me know. Or if you want to copy or take a screenshot of the page, you can type inside the chat, then I will let you take a look. Okay, I'll take a note of it. Okay. Now, let's look at this. Let's look at this. Question number 3. Very, very common O-level question on organic chemistry. They ask you organic compounds are placed in a homologous series. Give two general properties of a homologous series. Very simple. Homologous series just now in our mind map, what did we say? We say this, right? We say this. Same general formula, same functional group. Okay, same general formula and same functional group. Okay, go. Over here, what are two general properties of a homologous series? Okay, we tell them it must contain a same general formula. Okay, and the same functional. Oops. Now, students sometimes ask me, can you write down things like similar chemical properties? Can. Can. Because all of the compounds in each homologous series, they will react a similar way. For example, all alkenes react with addition reaction. Okay? Okay. Second one, write the general formula for homologous series of alkanes. Simple. This one we have covered just now. Okay, Ingrid, yes. High melting and boiling point. You mean melting and boiling point increases. Okay, then viscosity. Viscosity will increase. Okay, where viscosity will increase when the number of carbon atom increases. Remember bitumen. Bitumen versus petrol. Bitumen is very, very viscous, right? Because there's a lot of carbon atom. Can okay. Write a chemical formula for third member of the alkanes. Okay. Methane, ethane, propane. Okay, so it'll be propane. Formula will be C3H. It. Okay. Once you're done with the first part, can you try part B? Hey, meanwhile, if you have any question, you can ask inside the chat. Andy and Chloe, everything okay? Mukundan okay? Okay, those of us who are slightly quiet, if you have question, just let me know inside the chat. Okay, thank you, Mukundan. I see your thumbs up. Thank you, Chloe. Okay, thanks. Andy okay? Andy normally got a lot of question one there. If you have question, please ask. Okay, thank you. Okay, now we look at part B. Figure 12.1 shows the structure of this acid. It is produced by human skin, okay, when exposed to sunlight and whatever. Figure 12.2 shows structure of another acid, okay, made by all living organisms. It used as, okay, this kind of users. Okay, good. Now, first part. Does the test, other than the test for the carbon to carbon double bond, suggest one chemical test to distinguish between fumaric and malic acid? Okay, good. Now, can we first identify my first question? Most of the time, O-level first question is what? O-level question part one, they will tell you part A. Circle all the functional group in the two compounds. Okay, can we try this? Circle all the functional groups in the two compounds. Okay, circle and label them. So can you see this is a carboxyl group, COOH, COOH over here, COOH over here, COOH over here. Okay, so my question to you is this. Can any organic compound have more than one of the same functional group? Answer is yes. Can you see from here? We see that the same organic compound have two COOH group. Okay. Another groups, can you see CH bond? The other group is OH group. Okay. Ingrid, they say other than the test of carbon to carbon double bond, so bromination cannot use it. Huh? Okay, so once we have circled out everything, okay, we label them. This is normally the first part of the question. They will tell you to identify, okay, the functional groups in the different compounds. Okay, then can anybody suggest how do we try this question? What is the chemical test that we should use? So this one is out already. We cannot use this to identify. And we cannot use this to identify because both of them have. Why so hard? O-level very difficult. Do we need to know how to... Yes, Kaiji, you're right. Okay, wait. Do we need to know how to name the compound with two functional groups? Like in general, no need. No need. But if they ask you to describe, you just say dicarboxylic acid. This one we learn. This one we learn in we learn where? Which chapter we learn? We learn dicarboxylic acid where we are forming ester, right? Or we are forming condensation polymerization. Okay, dicarboxylic acid, which means something that have two carboxyl group. Okay, and but generally you don't need to know how to name. Okay, normally you just need to know how to name alkane, alkene, alcohol, ester, carboxylic acid also. That's all. Okay. Okay. Anybody have any suggestion? Okay, react with acid base. Says react with acid base. But if you react with if you react with base, can you see both of them? This one give you H plus. This one also give you H plus. So there will not be any difference. Both of them will react with a base. Okay. So Kaiji is right. Kaiji says use KMNO4. Yes. Okay. Oxidizing agent cause alcohol. Okay. Junming, I saw that you just joined us. Okay, later you can stay a little while more. Later I show you the summary sheet that we have done. Okay, then you can take a screenshot of it. All right, for organic chem. Now we are covering questions. So if you need the questions, you go to the Telegram group. Can Okay, good. So chemical test, chemical test is what? Chemical test at aqueous acidified potassium manganate. Okay, remember you must write this. Okay, D7 represent the oxidation state of manganese in aqueous acidified potassium manganate. Okay. So what are we trying to do over here? We are trying to do an oxidation of this alcohol over here. Can you see there's an OH group? OH group do what? It can oxidize. For fumaric acid, can anything oxidize? Answer is no. There's nothing can oxidize because carboxylic acid. Carboxylic acid cannot undergo oxidation, right? It can only undergo acid base. It can also, acid reactions as well as esterification. Okay. Okay. So what is the result? Okay. Purple KMNO4 will decolorize in malic acid and remain purple in fumaric acid. Can you see that? Okay, because the one with the OH group, this is the one with the OH group. This is the one with no OH group. And okay, any question? If no question, if you do you need to mention the need for the heat? Okay, you can mention the need for the heat. Okay, if not, you can just leave it. No need. Okay, if you mention, it'll be good. Okay, I explain again. Okay, look carefully. Figure 12.1 and figure 12.2. Fumaric acid has no hydroxyl group. There's no OH group. But malic acid has OH group. Based on what we have covered earlier about alcohols, okay, alcohols contain what? Alcohols contain OH group, which means that it can undergo oxidation because I can remove the two hydrogen atoms, okay, and supply a double bond oxygen over here. So with that, I can use this test as a distinguishing because one of them don't have OH, means they cannot undergo oxidation reaction. With that understanding, look at this. I will add the acidified potassium manganate into samples of both fumaric acid and malic acid. When I add in the purple color KMNO4 over here, is there any reaction? Answer is no, no reaction because cannot oxidize. But when I add aqueous potassium manganate over here, can it oxidize? Yes, it can oxidize. So there will be a reaction over here. So hence, this thing will decolorize. Can, Aman? And okay. Yeah. Okay, good. With that understanding, okay, now for all the students, okay, thank you so much for staying all the way here. Now, there are a few questions at the back, okay? These questions, it will be for pure chem only. Okay, it will be for pure chem only. Yeah. So if let's say that you want to try this question, you can go and try. Okay, it's for esterification. Okay. But for combined chem, okay, combined chem, you can try one of the part of the question. I can tell you which is the part of the question that you can try. Give me a moment. This one. Okay, combined chem, you can look at this. Ethanol to ethanoic acid in the lab. Okay, this is for question number 5, part 4. Okay, the rest of the questions, I think most of them only pure chem can do. Okay, now I'm going to go through very quickly question number 4. Then after that, we shall call it a day. Question 5, you can do by yourself. Okay. Question number 4 is talking about methyl acrylate. It's an organic compound, okay, to make acrylate fiber. Now, for combined chem student try this. Combined chem student only. Look at this structure. Attempt part C. You can do one for combined chem. Okay, you can do one. This one. Okay, try out this while I explain the rest for the rest. Okay, now they tell us that methyl acrylate produces acrylic fiber, which is used. Okay, this is the structure. Now, first off, identify what are the groups present. In this case, there is a carbon to carbon double bond. Can you see over here there is an ester linkage? This is the ester bond. Okay. Now they tell us that methyl acrylate is formed by the esterification of alcohol X and acrylic acid. Now remember A, B, C. Alcohol before carboxylic acid. So hence you split it here. Yes, you are right. Answer is methanol. How to draw the structure of acrylic acid? Acrylic acid is what? Okay, so look at the structure again. Which side do I break? Which side do I break? CO, I break it here. Okay, break the ester linkage here. So here come from the acid. Here come from the alcohol. Can you see that? Okay. Can Okay, so with that, then you try to draw the structure. It will look something like this. Double bond H, C, O, O, H. Okay, that will be the structure of the acid. Can Okay. Now, part B, methyl acrylate can undergo polymerization to form polymethyl acrylate. Draw the structure of polymethyl acrylate. Okay, so they will undergo polymerization. This one, I think I will leave it to you. You go and draw. Okay, follow the steps that we have gone through previously. Okay, how to draw polymethyl acrylate. Now, this part, combined chem students, okay, and pure chem students as well. Sample of methyl acrylate and sample of butanoic acid. They tell us that both of them are isomer of each other. Isomer means what? Same molecular formula, different structure, right? So in this case, do they have same molecular formula? Butanoic acid is how many carbon? Meet it prop but. Okay, 4 carbon. C H. Sorry, we always follow general formula. CnH 2n plus 1 COH. Okay, so it will be what? C3H 7 COOH. This is butanoic acid. Okay, can we see? In this case, how many carbon atoms do I have? 1, 2, 3, 4. 4 carbon atoms. Okay. How many oxygen atoms do I have? I have 2 oxygen atoms. Okay, how many hydrogen do I have? 1, 2, 3, 4, 5, 6. So are they isomer? Answer is no, they are not isomer. Why? Because isomer requires same molecular formula. Do they have same molecular formula? Answer is no, they don't have same molecular formula. All right. So answer for this question, nope, they are not. No, they are not isomer. Okay, because isomer, remember, they must have same molecular formula. Okay, and what? Different structure. Okay, can Okay, any questions? If not, can you give me a thumbs up? Okay, if you don't have any more questions for me, maybe you just help us to upload our Instagram story and then you just send a photo to me. Then I'll send you all the revision materials by today. Okay, if not, then that's it for today. Then I will see you the next time. All right. Bye-bye. Thank you so much for attending.